Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and today we're going to be taking a look at the Hailo-8 AI coprocessor for the Raspberry Pi. We're going to be using it on a Raspberry Pi 5, and it's going to be an exceptional way to bring edge computing to the Raspberry Pi and to your next project. So before we get into it, be sure to hit that like button and subscribe if you haven't subscribed, because we're about to get extended. Let's get right into it. Okay, so we're going to be talking about supercharging the Raspberry Pi using the Hailo-8 coprocessor. And I don't know if you noticed, but I added a cat cam just because she always wants to be on cam. So I figure why not let her. Actually, I got this great desktop stand for her to sleep in, so she likes it a lot. All right, so this is the Hailo-8 right here. And it is just a NVMe format, but it connects PCIe to the Raspberry Pi itself. In this particular case, I'm running triple decker, so I have an NVMe adapter hat, a PoE hat, and then, of course, the Pi. So it is very low power. It's about 2.5 watts to actually run the Hailo-8 itself. It's 26 tops, which is the speed in which everything is measured. You know, all of that as far as AI is concerned. But that brings a significant amount of horsepower to be able to go from, you know, potentially a dozen frames a second of processing of things like video, which is what we're going to be demonstrating today, to actually couple, 100. So a significant increase in terms of what the capability is. So going right into it, we're just going to be going through a quick deep dive. This is not sponsored. It's just something I bought with my own money to check out because I thought it was cool. And to be honest, at that time, the Jetson Nano was out of stock. So maybe I'll do the Jetson Nano in the future, especially if there's, if people want to see more content like this. So this is more of a how to get started in the Hailo-8. So with Edge AI, it's running artificial intelligence algorithm locally on the device. So it avoids having to send it to the cloud. It's great for offline projects. It's good for, dealing with latency, privacy, bandwidth, and reliability. As far as, when you actually need to process the video or any kind of text, if you need to do large language models, etc., image generation. It's a great way to be able to do it locally, not have to pay monthly fees or anything else like that because you own the hardware. And at the end of the day, because it's not going across the internet, if the internet goes down, you still have access to this capability. So it does add a lot of flexibility in terms of what you can actually do with it. The hardware itself is a really good match for the Raspberry Pi 5. So the Pi 5, 2.4 gigahertz quad core, 64-bit, with its own GPU, but again, the GPU is not as powerful as a dedicated GPU. It is shared memory, everything else like that. In this case, we are going to use an 8 gigabyte Raspberry Pi 5, but you could use the 4 gigabyte as well. And the big thing that makes this possible is the PCIe 3.0 X1 interface. By default, it's 2.0, but I'll show you how to change the speed of that to 3.0 in order to get better performance. Otherwise, it will cap your maximum throughput and you won't be able to leverage the full capability of the Hailo-8 hardware. The Hailo-8 hardware itself, it's an M.2 key, and it has up to 26 tera operations per second. So that's just the pretty much how fast it can compute. Again, it is running pretty much like a GPU, where it's running in parallel. I don't know what was happening there. Where it is running all of the computations, everything else like that in parallel. The power efficiency is amazing at about 2.5 watts. So it is very good for a good match for the Raspberry Pi. You don't need any special additional power supplies or anything else like that if you did try and do an external GPU. But it's a specialized chip built from the ground up, specifically for neural networks, and it delivers really good performance. They say data center performance, but at the end of the day, it's very good. I did generate this presentation with AI, just if anybody's curious, I do have a copy of it on GitHub as well, along with a lot of additional information and a lot of the resources that were used in order to write it. So what is a dedicated AI coprocessor? So a CPU versus the Hailo-8 for AI tasks, right? So a CPU can do anything, but again, it's more tuned towards sequential workloads, minor parallelization. We can only do 4 tasks at a time on the Raspberry Pi 5 just because it is quad core. So at the end of the day, it can do a little bit of parallel processing, but not in the kind of scale that we need in order to make AI efficient. So they require doing millions of repetitive math calculations for neural networks. So a dedicated NPU, as it's called, like the Hailo-8, is specifically designed for that. So the disadvantages, like when you run AI on a CPU, you'll get high CPU utilization, and it'll often just be pinned at 100%, and you'll be waiting and waiting for whatever you're trying to process to come back. Has slower interface speed, so low frames per second, especially if you're trying to do video, which tends to consume quite a bit, as well as it uses more power for the same equivalent task because it's trying to kind of down convert and make it a simpler operation and then do it repetitively, which uses a lot of power. So the systems can become unresponsive or when the CPU is bogged down, or it could just consume all of your resources and everything else grinds to a halt or loses priority as a result. So offloading AI to the Hailo-8, you get very low CPU utilization, which is usually less than about 5%. It's massively faster interface speeds for real-time performance, extremely power efficient as far as tops per watt than you can get with a CPU, and it frees up the CPU for the OS and other applications. So it makes it so you can now do even more with your Raspberry Pi, like hosting web servers and things like that, or being able to do recording of video and other things. So it definitely makes a huge difference in terms of what you can do with the Pi itself. And some of the things that you could do, like commercial and industrial, you could do smart cities, like doing real-time traffic analysis. An example of that being like doing car counters. So visual car counters where previously they would have had like a rubber pipe, a couple of rubber pipes running across the road and checking how many pulses they get, which can be thrown off by a number of axles, things like that. This is just going to count the number of cars and trucks and differentiate between the two. It could do license plate recognition. I haven't tried it with this particular one, but if you have a high enough quality camera and you're focused in the right place, you could technically do character recognition is really what it's doing. And then smart parking, I don't know about that. That would take quite a bit of a lift, but theoretically it is possible. Retail analytics for being able to see where customers are actually going inside of a store, to be able to see what's the high traffic areas, what are the popular items, things of that nature. And industrial automation like visual quality control on assembly lines, safety detection to tell if a person enters a restricted area while a machine is running. You could stop the machine, although I wouldn't, again, I would get a pre-built a pre-built device that does that exact type of thing. I wouldn't try and make it so you're building your own safety systems unless it was something that couldn't injure you. But again, it is something, predictive maintenance alerts, things like that, if you wanted to define trends. But more relevant to us is like home and hobbyists. So advanced home security. And we're going to be covering one of the use cases here today in terms of person detection versus like animal detection, things like that, to be able to determine, is it just a bird that flew through the frame or is it an actual person? And a lot of cameras, things like that, will do that these days, but realistically, if you wanted to build it yourself from the ground up, this would be a good way to do it. And then robotics and drones in terms of being able to determine what the best path is and how to actually navigate a particular terrain all on its own. you could use it for that, and it's excellent for that, as well as just other creative projects like real-time gesture recognition, smart wildlife cameras that look at species and things like that. Of course, you have to have trained AI in order to be able to do that. But again, the world is your oyster. It's all about what you actually load onto it. It's just a processor, so it will accelerate whatever AI is that you can load onto it that's compatible with it. So as far as actually getting started, right? So we kind of went over what all of this is. And one of the main things that is really nice about this is that it has all of the repositories and the packages built into the main Raspberry Pi OS repository. So you don't have to add any additional repositories or anything like that. You used to, but they've integrated it, which I think is really nice. And I've done a lot of this work already, so we're just going to kind of go through the motions, just because some of these processes take like 10, 15 minutes, and I don't want to make you wait that long having to hear me kind of fill time. So we'll go through this one step at a time, but you'll notice a lot of the stuff is already either installed or in place. So first thing we need to do is we need to make sure that everything is up to date. So we need to just update our system using sudo apt update to get the latest list of packages, and then do sudo apt full upgrade to make sure that we have the latest version of all of the packages installed, and the -y automatically accepts it so you don't get prompted for anything. And again, I said I did this earlier, so we don't have to do that. The next thing is we're going to install the Hailo software stack, right? And what this is it's all of the drivers, because this does require drivers. They're not included by default with Linux, as well as runtime libraries, firmware, and other tools. So they came up with a shortcut for it, which is Hailo-all. And that makes it really easy to be able to just copy right in. And again, this is going to be there, but what this is going to do is it's going to pretty much put in a ton of dependencies. And there's a lot of, it is based on Python, these particular examples and things like that, and a lot of the best ways to interface with it is through Python. But at the end of the day, it is something where it's just an easy way to get started. And then the big thing is we need to enable our PCIe X1 interface to be Gen 3 speeds. So best way to do that is raspi config. And we'd scroll down to advanced options and then go to PCIe speed. And then would you like Gen 3 to be enabled? I did this previously, so we hit yes. It says it's enabled. Go to finished. And then if it prompts you to reboot, you reboot at that point. Now, at that, you should already have everything connected as far as the actual Hailo-8 is concerned. So when it does reboot, it does load all of those drivers, initialize the chip and everything else like that. Otherwise, after you install it, otherwise you'd have to boot anyway. But it would do that at that time. I haven't noticed that it actually breaks it or anything like that, depending if you installed it after the fact. But realistically, I just find it easier to get your hardware set up and then install the software accordingly. So now that we've done that, we can go into our examples. Okay, and first thing we have to do is we have to do git clone on the examples, and this comes from the manufacturer itself of the Hailo-8. Hailo is the company, 8 happens to be the model. I don't know why they called it 8 when it's 26 top, but, you know, what do I know? But there's Raspberry Pi specific examples that are really useful. And pretty much I've already got that here. So we see the Hailo Raspberry Pi examples. I just put it in my home directory, which happens to have all of these other files, but it doesn't really matter. It does download it as an individual directory it is easy to update at that point if they do make changes or you want to reference it in the future. So next, we're actually going to run the object detection demo. So what we're going to do is we're going to, and I would actually do this one line at a time, just based on everything. It is actually going to, it's going to prompt you when you do the install command to say yes. And I'm going to try running it here again. Hopefully we don't break everything. Otherwise we'll have to fix it. But at the end of the day, that's not too bad. So this is actually the quickest part of the whole thing. But we do install.sh, and I think it'll actually run through the entire installation process, but it won't have to reinstall or re-download anything that's previously installed or downloaded. So ignore all of the warnings at the end of the day. They're not going to affect the operation or anything else like that. But what this is going to do is create a virtual environment with all of the needed dependencies to be able to run the AI examples. Right, and it's, again, virtual environments are very good for being able to, I would say, do non-standard things with packages, opposed to having to install the packages globally or anything else like that. But to activate the virtual environment, similarly to like how we did on the last video or the last stream, is we're going to do source setup env.sh, which will, in this case, pretty much load everything that we need in order to be able to run this. So now we see it says venv, which is the virtual environment and the directory that it created as part of the install script. So we can go ahead and run one of the basic pipeline examples, which is the detection simple dash I USB. And I already have a USB camera connected to this through just the regular USB interface. I probably could have hooked it up USB 2. It doesn't really matter what kind of camera it is. And I'm just showing the USB camera, but it does support the onboard camera. It supports any number of things. I mean, you could actually feed video directly into it, and it will do it on video that was previously recorded. And again, the kind of camera doesn't matter. So we're going to pull back the curtain of the of the fourth wall here. Oh, I didn't copy it. Let's copy it first and then paste it in. And we see that, right, you see my green screen. It actually is very low delay. It says with almost 89% certainty that I am a person, and I'm very happy to hear that. So that's a very good thing. You can see the green screen I got going on here. And if I move this over to the left and bring over the console a little bit to the right, we can see how fast these frames are coming by. And we see how low latency it is based on, you know, as I talk and everything else like that. It still looks pretty close to real time. Even though it's displaying it, you know, processing it and coming up with the overlay over top of it, it's still showing us, you know, that it is adding a lot of capability. Brian says quick, but I don't know if it's the overall project or what, but thanks for joining, Brian. I appreciate that. And then it's a good way to be able to determine detection just based on monitoring the actual output from like this script, for example. So if we were to face this over towards the cat, we could see that it has good confidence that there's a cat and a bed. So we can see that there's a person, a cat, and a bed in this frame. So it's able to detect, you know, if an animal like is going to go into their bed, it could kind of define what exactly they're doing and everything else like that. I'm not sure if it can tell what this is. So it could tell it's a bottle. At one point it thought it was a cell phone. You know, again, it's based on confidences. So as far as the actual, you know, identification, it's only as good as your neural network is trained to be. So at the end of the day, I think it is something that has a lot of capability, and you have to be able to make it tolerant so that way if it is something that is going to, you want to go based on consensus. So over time across the frames, the one recurring thing is that there's a person in there. So the things that pop by and zoom by really quickly are going to be things that you're not necessarily going to want to, you're going to want to ignore those as outliers. And I think that that's kind of how it goes. It's a statistical thing. We see bottle. Is it a bottle? A cell phone? Thinks my head's a baseball. Wonderful. It's jury's still out. And also, if you have detached limbs, which let's see, it'll think it's a different person. So I think it's just a really cool way to be able to try and do, different types of identification and reaction control. So instead of having like a motion sensor or something else like that, if you want a light to be able to activate only when there's a person present and not when there's animals or other things present, you could be able to use something like this to be able to do that just based on whether you see a detection of person with a certain amount of confidence detected. And I think that that's something that's going to definitely make it very powerful for just using in general projects without having to do a huge lift to be able to kind of bring these things up from scratch. You could be able to build on other people's projects, things like that. So we'll close out of this really quick. It'll automatically exit out of here. I would always, you know, make sure if you're in your virtual environment that you're doing things that you intend to do in your virtual environment, just because it won't apply to your full system. So make sure you close that out as well. But going on from there, some key conclusions and takeaways from this. So there's definitely a paradigm shift towards edge AI, right? Because while data centers, everything else like that associated with AI are great for being able to spin up things on a temporary basis, you still have that internet dependency and you're still dependent upon somebody else and then transiting your information to the cloud and then getting back the result. So there's a certain amount of latency and overall, reliability considerations that make edge AI computing very appetizing. And then it's also very incredibly accessible. I think I paid less than $200 for the Hailo-8 module, and obviously, a bit more. It turned out to be more than the NVIDIA Jetson Nano, because including the Pi, the PoE had all of that, where and it's a little bit. It's about I would say a little less than half the speed. I think the new Jetson Nano is about 67 top, where this is 26. So if my math is mathing, that is less than half. So at the end of the day, it is something where, depending on what you get and what you're trying to do with it, this is, I believe, a bit more power efficient than the Jetson Nano, which does have slightly more processing horsepower as well as obviously more tops. But you may not need that for your particular project. Like as you saw here, it was flying by at full frame rate of the camera that I connected to it, and potentially could do multiple cameras depending on how I set it up, things like that, just because that's the power of the hardware. And heat wise, anything else like that, just touching it doesn't need a heat sink. It does have an integrated heat spreader and whatnot, but it's I would say warm to the touch after what we were just doing. And I think even over extended periods of time, it probably would not have an issue staying cool as long as it wasn't, directly in the sun and in the desert. So, and then of course, limitless potential in terms of it really opens up vast ranges of real time, private, and reliable AI applications that really weren't in reach for hobbyists previously. So you would require having either huge power consumption associated with servers and full graphics cards and things like that, or you were limited in what you could actually process at a given time, which meant either robots were slow or things just were completely out of reach. So it's definitely something where it's coming into the mainstream in terms of making it available to anybody who wants to include it in even trivial projects. Important to you, but on the grand scheme of things, just things that would work for you, opposed to being products that would have to benefit from economies of scale. So thank you for watching today. If you do have questions, and there are some resources, I have posted this presentation on GitHub as well. The link is in the description. If you have any ideas for projects, or if you've experimented with AI yourself, tell me about it in the comments. I definitely love to hear about it. I try and also I definitely read all the comments, and I try and respond to all of them as well. So be sure to share. I definitely would appreciate that. And but here's a few links to manufacturer as well as Raspberry Pi, just in case you want to take a look for more info. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you know anybody who would like this kind of content, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. And if you haven't subscribed, please subscribe. It helps me out a lot with the YouTube algorithm, and then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.